go and sit there and say 280 in all. Some are blue, some are red. Look at how I scribble on this. Look at how I do what a mathematician does. Wait a second. I got left. No, wait. He used 1/3 of the blue. Is that what that says? Yeah. So I got 1/3 of these blue were used and 1/2 of the red were used. And then I know that what was left was the same. Is that right? Is that what it says? So if I use 1/3 of the blue, how many blue are left? So 2/3 of the blue is some number, and it's got to equal 1/2 of the red that are sitting there left. And you know, I mean, I'm stealing all your time. I mean, right now, if Peg was here from yesterday, Peg would say, shut up and let them struggle. I'm doing a terrible job. Some of you are saying, thank God you're not squeezing my brain. Others are saying, you're cheating me out of the opportunity to play with this, to see this. Right? So I want you to sort of see that I can work this thing out in sort of this algebraic fashion, and then 2/3 equal to this. Well, but what do I do with half is red and 2/3 are blue? And what does that have to do with 280? Oh, 280 is all of them. But I don't know about these things. I know that these are equal. 2/3 of B equal. I mean, some of you are able to sort of do this. You ready for this? I have blue cups. Agreed? I know that I use 1/3 of them. Agreed? And I know that I have 2/3 that are left. I have my blue cubes. Why I have not done this on a slide so that I don't have to draw these pictures is beyond my powers of comprehension, but I just added this and I didn't think about how the next time I do this, I'll do it. Then I have red cups. What do I know about red cups? Well, here's what I know about red cups. I know that half the red cups are left. And half the red cups are the same amount as the 2/3 of the blue cups. Oh my goodness. Without a picture, without a representation, right? I don't know how to solve this. Why is it that kids in Singapore do so well? Our model gives them access to things that most American kids can't do. Because if I go back over here, you're sitting there as I am about what to do and not. And then I've got this other group that is 1/3, 1/2 that is of the red that are used. And this is what's left. But that's my connection thing. Now, all I know is that, let's see, 1/3, 2/3, so that's 1/3. 2/3, so this is the same amount as this. And this is the same amount. Holy moly! 1, 2, 3, 4, 5, 6, 7 pieces that add to 280 cups altogether. There's the model. There's the representation. I have just empowered kids to be able to make sense of this. That means this is 40, 40, 40, 40, 40, 40, 40. There are 80 here and 80 here. There are 80 here, and then there are 40 here. Look at this. Now go play the numbers. Right? These are the same. I got 40, 120 of the blue. 80 and 80, is that right? Yes. 160 of the red, and the whole thing plays out. I race through that. I know. I want a faculty meeting in every one of your schools, led by you, with this idea of productive struggle and representations. I want your colleagues to say, I hate it, I hate it. And I want you to say, I did too 3 years ago. That until I started using the bar model, until I recognized the power of representations. And so, again, this is the part that I didn't do yesterday, that I did today, and I'm going to change this because I don't like what just happened. But it raced through, and it gives you some sense. We know that it's about discourse, and there they are. And so you can't read that, but that is the classroom wall in Kendra Scarborough's room in Hazelwood. That's 5 years old. Kendra listened to me talk and she put up the discourse clouds. It says, why? How do you know? Convince us. Explain that, please. How did you picture it? You can't see that? Big deal. There they are. Yesterday, there were people tweeting this slide all over the place. Steve's discourse clouds. Let's go put them up on our wall. Ladies and gentlemen, it begins with the generic. It begins with, I don't care whether you love math, hate math. I don't care whether you're comfortable teaching it or not teaching it. You know that on the basis of everything we've done today, to the degree that you have kids helping you by pointing at those signs, to the degree that that's not decoration over the interactive whiteboard, to the degree that kids say, ask me to convince, ask me why, ask me how I saw it, to the degree that we all as a school become comfortable in every grade and every class beginning in kindergarten. Really, why? How do you know? Convince us. Can you convince us? How'd you picture that? Who did it differently? And then there they are. What do you notice? What do you wonder? And then the most powerful ones of all, construct viable arguments and critique the reasoning of others. I cannot critique the reasoning of others unless two kids have got their whiteboards next to each other. How are they the same? How are they different? How can they both be right? How come one is right and one is wrong? I don't understand. How can the answer be 28 centimeters on Jennifer's whiteboard and 280 millimeters on Jeffrey's whiteboard? Try to tell your partner what my problem is. You know that 5 minutes later the kids go, I don't know why I have a problem, they're equivalent amounts. What do you mean they're equivalent amounts? Well, everybody knows that there are 10 millimeters in a centimeter and therefore 280 millimeters, and you sit there and go, I don't think I understand that. Who can explain Jake's reasoning? Only had J's in this class, right? Who can explain Jake's reasoning? So I got Jennifer, right? I got Jake. Who's the other? Jeffrey, right? And I got Jonathan. Super. We pose purposeful questions. I mean, by now, this is just a giveaway. But now you realize that what we're really saying is, how do we recognize that answers are important, but they're only a way station? That good math begins with an answer, often a wrong answer. And that is a fundamental mindset shift that you either have or don't have. We build fluency from conceptual understanding. So you ready? We did this already, all right? It is not about 17, because I know it. It is about all the things you did, right? Not this, but convince me. Convince me that 8 plus 9 is 17. On your mark, get set. And so you hear all the things that you did in this room, right? 17, I knew it, cool, great, thank you, right? 10 plus 7, where'd that come from? That's called compensation, right? That's called add 1, subtract 1. That's different in your brain than the kid that says, wait a second, decompose the 8 and the 7 and 1, and then use the associative property. Oh my goodness, no, wait a second, I did the double minus 1. No, I did the double plus 1. And I don't know about you, but every class of 2nd and 3rd graders I've ever done this in has a kid that says, easy. What do you mean easy? It's just 20 minus 3. And you sit there and realize that kid has lived with 10 frames and knows that 9 is a 10 frame with a hole. 8 is a 10 frame with 2 holes. That is their mental image that allows them to become facile with mathematics. Representations, different approaches, the discourse that goes on. Who's right doesn't matter. We talked about 7 times 6 is 42 and all. There it is, your turn. Oh, yes. Ready? 1/10 of 450 is, don't say it. You think you know it? Awesome. Convince me. Compare that. Look at the difference. Look at the difference between every time I ask 3 questions like this. What's the answer? I say to the kids, convince me now that it is the answer. Your turn, gang. Convince me that 1/10 of 450 is 45. Go. Hey, great, help me with this. Ready? Hands. How many of you are so smart that you said so multiply by 1/10 and divided by 10? Hands. Look at that. Look at all the hands that are smart enough to realize it multiplies by a fraction. Right? When you can divide by 10. Good. Who chopped off the 0? Because that's what God said to do. Who moved the decimal point one place to the left and got 45? Neat. Who took 10% because it's a 10? What am I missing? Who did a picture and actually their brain saw 450 divided into 10 pieces? Who did as a multiplication problem and said 10 times what is 450? Oh my goodness, look at that. Why are we all right? What's mathematical understanding? Mathematical understanding is not the one right way to get the one right answer. Mathematical understanding, this class, these kids are empowered by the fact that why is it that multiplying by 1/10, dividing by 10, chopping off a 0, and moving the decimal point one place to the left, all give you the correct answer. That's what's important. You don't have to know all that ahead of time. When you ask kids, how'd you do it, how'd you do it, how'd you do it? And we then have all those different approaches and methods. And we then can talk about how and why are they the same and where did they come from. Good? We have this struggle. And so if we had all day, we would do this. I just gave you a struggle problem. I gave you one, so I don't even know why I had this in here, because we did struggle with this one, except again, if I'm smart and write some notes to myself on the plane today, I'm back to this one. I would have spent more time on this. I would have let you struggle. I would have said, what is the problem? Why are you wrestling with this? I would have made you do this on a whiteboard. Why? Steve's latest rule, the first half of every single class should be done on a whiteboard where kids can easily erase it. I'm in more and more schools where the tabletops are whiteboards, and the kids can write on the whiteboards and then erase it. There is something so wonderful about the fact that you write bigger and you can see it and you can erase it. And then the second half of every class is when you start doing your stuff on pencil and paper. Because I do need a record of it. You need a record of it in that way. And so the productive struggle comes from the tasks. You knew that the kids were struggling when we worried about the watermelon and what the watermelon really was. And we elicit evidence. Because when all is said and done, I ask you, how difficult is it? Can I remind you that I've sat in 150 math classes since September, over the last 10 months. I have seen a formative assessment exit ticket in 12 of 150 classes. We don't see it. We don't do it. We don't believe it's essential. You all know that all the research says that it is the single most impactful effect size change that we could make. And so when we know how important it is, I say to you, that's part of what we have to worry about. That's what we have to do. And so how hard is it to assign 2 5-minute markers, 2 5-minute monitors? With 5 minutes to go, it's like, hey, it's 5 minutes, Mr. L, 5 minutes. I go, awesome. Click, click, click. And look what happens. What'd you learn today? 2 minutes. Turn and tell your partner, what'd you learn today? What'd you learn? What'd you learn? What'd you learn? Awesome. Let's see if you actually learned it. There it is. Let's see. You go do this exit ticket. You go see if you can do this and make sense of it. And so, gang, take a deep breath. Take a deep breath. Here is my other gift to you, gang. This is all brand new stuff in the last 6 months as I've tried to capture this stuff. 1, what are you trying to accomplish today? Well, what is your goal? Okay, how nice. You just did a first draft of your opening lesson goal slide. This is the backwards mapping. I have a goal, and now I ask the question, how will I know it's been successful? Kids will be able to do this. Kids will be able to explain this. Kids will be able to solve this. Awesome. I just built my last slide. I built my exit ticket slide. I now sit there and say, how do I move from that goal so that every kid can be successful on that exit ticket? Well, lo and behold, I have to have kids do this task. No, this problem. No, wait, I have to ask these questions. No, wait, I build my lesson around the tasks, the examples, the problems, the activities that will maximize the chance that they're going to be able to do it. I steal them, I find them, I put on my slides my questions, I put on my slides the diagrams, the pictures that they need. And then I stop and say, yeah, but they will be able to do this unless they have this prerequisite knowledge. Well, cool. And now I back up to my warm-up slides. What do I need to know? What's the prerequisite knowledge to be able to do that? There it is. Those are the 4 questions. That's all we talk about. And that means that I then end up with a collaboratively developed 5-slide lesson, a 7-slide lesson that has my objective or lesson slide, like you said. I've underlined the key words. I got my warm-up slides, my task slides with questions and graphics, my what did you learn today slide, and my exit ticket slide. Good. Good morning. Boys and girls, we are back in Nito. Today we're going to solve what? Yes, so I want to know if you guys know what a problem is. Turn and tell your partner what's the problem. Blah, 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 all that kind of stuff. What kind of problems are we going to solve today? That's right, problems about addition and subtraction. How nice. Good. Let's see what we already know. On your whiteboards, guys, number 1 to 3. Okay? I knew that I was in problem. I knew right then and there this class was going to be a disaster. I knew that I was set up by these teachers because it was astounding how many kids had no clue that 17 was 110 and 7 ones. The kids struggled with 3 plus 5, and the teachers in the back of the room were sitting there going, oh my God, this is so embarrassing. The principal's in the room saying, are you kidding me? These kids don't know what it is. And so we went on, but this was the best discussion we had. What did it tell us about what had not worked? What did it tell us about Worksheet Heaven and how it had been a disaster for these kids? Right? So my formative assessment tells me so much, right? How did I salvage this? I salvaged it because the last question was, how many pens tall was I? How many markers? It was unbelievable. It's the first time these kids have been failing, and all of a sudden they guess, they look. And so I'm standing up there and I got this marker. Ready? All of you, right now. How many markers tall am I?
30.
That's good. 30, 17, it's great. All right, ready? More than 20, less than 20. More than 20. Less than 20. Oh, nice. That's an even division of the house. Good. Less than 15. More than 30. Write down the number. So I wander over to the side of the room, right? I come and I'd love to just do this the right way and write a little mark. So I make this little mark right there. Right there it is. I can see the mark. I really want to do this, but I don't care. It's amazing. Normally I would do that. So I know where I'm going. So I'll start right there where I was. 1, 2, 3, 4, 5, 6. Anyone want to change their guess? What you do? Anyone want to sit there? I don't see it. I can't see what you're doing, right? 7, 8, 9, 10, 11, 12, 13. Dumbest kid in my class goes, 14, I told you, right? The kid's sitting at the palm of my hand. And so that salvaged things, because before that the kids were convinced that I was a crazy man asking them things they couldn't do. Right? So it's the same thing we've seen. We did fruit sale, right? And we've got our questions built in. And so look at again how we designed a lesson that allowed us to be in control. A lesson that allowed us to give all of that power to kids. We animate them with the questions. And so look at how this one is connected to the one we looked at before. Look at how we share this, and then the second grade teacher says, oh, if you did this, I can do this. And then the third grade teacher says, wait a second, then I can do this, right? Show how you know, show how you know, right? Then we change it. Salad. So, bottom line is, we got these slides, you see the way they work. Look at that. I love this. I mean, the teachers made me do this. They say, Mr. L, Steve, we're tired of everything coming in from the left. It's boring, it's boring, it's boring. I go, all right, fine, we'll plumb them up from the bottom. You know, the kids go, did you make a mistake? I go, yeah, I made a mistake. But you know what? You're happy, they come up from the bottom. Right? It's like, you know, we play with the carrots in the festival. I gotta tell you something, you go take this lesson and go try it out with your kids. You go take a lesson, adapt it, turn and tell your partner. There it is, 6 slides, that's the whole thing. Turn and tell your partner what worked, and then peas, pesos, apples, pears. Let's see if we learned anything today and done, right? Solidify our understanding of fractions. Oh my goodness, look at this. So now we have a review lesson. Oh, I've been having more fun with this one. Late in the year in 3rd grade with all the fraction stuff. Look at the goal. That's a goal you've never taught before, right? That goal that says, today our goal is to solidify our understanding of fractions, including equivalent fractions, ordering fractions, and being sure we don't fall victim to the common misconceptions. Boys and girls, turn and tell your partner what Mr. L's crazy goal is all about. He's not making mistakes. What kind of mistakes? Oh, what's the difference between a mistake and a misconception? All I have is to remind you that this lesson now says, tell me what you see. I see a pizza, I see a circle, I see pepperonis, they're invisible. I see spokes, I see a wheel. Come on, gang. Turn and tell your partner how you know it's a circle. Yeah, you want to go Google that real quickly. You don't even know why it's a circle. Right? It's a great question for kids. It's so great listening to kids say it's a circle because. They have right answers, they have wrong answers. Good. Actually, gang, it's a pizza. So, this is it. 4 slides, and I've taken care of... Tim eats a half the pizza. Sarah eats 2 quarts of the pizza the same size. Who eats more? You got kids sitting there on their whiteboards. 2 points. 2 is bigger than 1. 4 is bigger than 8. Good. Another kid says, oh, that's the same amount. How do you know? Without a picture, you can't convince me. Without a picture, we don't understand what's going on. What am I doing here? Equivalent fractions. Same size pieces and understanding the notion of the whole. There it is. Single most common error known on the planet. Everyone knows that if Tim eats a quarter of the pizza and Sarah eats a fifth of the pizza, then obviously Sarah's eating more because 5 is more than 4. You've never taught this to kids without kids convincing you that in fact it has to be more. You sit there and say, who eats more pizza? How do you know? Show me with a picture. The 4th is smaller. No, the 4th is bigger. The 4th is bigger because there's only 4 pieces, and we're back to the big idea. Then I got this wonderful Sarah. So we sat, this is really fun. I mean, I sat there with a group of teachers who we sat there and said, what else are they confused? They're confused about the whole. I go, okay, cool. Tim and Sarah both eat half the pizza. Tim says they both ate the same amount. Well, they both ate a half. They ate the same amount. Sarah says, no, actually that's not true, right? Sarah ate more than Tim. How's that possible? Good. I love it. All right, gang, we're winding down, right? Show me with pizza drawings how Tim and Sarah can both be right. What do you mean they both can be right? You all know that if Sarah's pizza is bigger than Tim's, then her half is bigger. That whole notion, all the misconceptions play out. Good, let's see if we learned anything. There's a formative assessment. You do this one right? Tim is a quarter, 3/4, show this. Sarah eats 8 slices, Mary has an 8-slice pizza and eats the same amount as Tim. Show this. How many slices does Sarah need to eat so that they eat the same amount? When you get this correct, I sit there and say, you have mastered the 2 critical objectives for 3rd grade, common standards, and all that stuff and how it plays out. I'm not going to do this one because it's not important today. I'm not going to do this one. I'm going to say that there they are. That's the template we've been talking about. Ladies and gentlemen, what a pleasure. Thank you so much.